So this is one of those things that I've been working on for a while and I haven't posted anything, so I thought I'd make a video blog kind of to demonstrate where I ended up in the whole mix of things. Um, Basically, this project started out of, um, I don't know, passion to sit up here and help my daughter and probably people like her. My daughter was born with VACTERL, and one of those things that she ended up in VACTERL association was a limb deformity called radial club hand or radioplasia, radial ray aplasia. Um, Basically what that means is she was born without a radius bone in her thumb. And so, there's several different options to treat this. Usually they use a forefinger. If we can look at this part here, the forefinger, and they move it over as a thumb, call it pollicization. And then they do either centralization or ulnarization, where they move the hand over the top of the ulna, the remaining bone, the one that connects, makes your elbow joint, or the ulnarization kind of puts the hand on the other side of the ulna. Both of them have a little bit of, I think, drawbacks. Usually there aren't too many revisions when you do a ulnarization. But centralization surgery, you can get several revisions to free up scar tissues, and it basically reverts back in an interned position. It's kind of like 90 degrees to the bone. Your hand is. And so I was thinking about, well, what are the alternatives so she doesn't have to go through that many painful surgeries? And so I thought, well, there's a lot of people 3D printing stuff. And today there are some manufacturers of some software, really good manufacturers of software that allow people to download their software and use it absolutely free of charge as long as they're not making over $100,000 a year. And Autodesk is one of them. I don't really have a design background per se. I did start in drafting, mechanical drafting and stuff like that, all the way back in the 9th grade and through 10th through 12th. Did some architectural and civil stuff, and then into college a little bit. I also helped implement the first CAD systems within LPS when I was a senior, I believe it was. My industrial arts instructor, Jim Hesse, actually asked me if I would be willing to stay after school and help teach the remaining instructors for Lincoln Public Schools systems to learn how to use CAD. We didn't have AutoCAD at the time because it was deemed too expensive. We had something called CADvance, but then I used AutoCAD, which was considered an industry standard back then in college. But the guys that were doing mechanical engineering, they started using stuff called SolidWorks and things like that. And Autodesk Fusion 360 is kind of a reimagining of that type of thing, or a reimagining of Autodesk Product Inventor. And I'm glad they came out with it because it's a lot easier to do things in it than other software. So I just kind of explain a little bit where I started out. I don't know what my memory limits are right now on the machine because it seems to be running just a little bit slower. Fusion takes up quite a bit of resources. I have a large model loaded into Blender too to show some differences of things. But basically, this software here is what you call a parametric modeler CAD program. And it uses T-splines, which are these lines here, whatever they are. They're not important to know for the layperson, but it's pretty powerful. So anyone who has any type of background of design or with using certain types of CAD software similar to this, you can sit down with it, and in about an hour or so, you can probably get used to doing a lot of design work. And so what I did after I got out of college, or shortly in college when I was doing CAD, is I started getting into visual effects software. So visual effects software is completely different from this. Visual effects software is what you see being used in high budget movies and things like that. And they're all based, many of them are based on a polygonal modeling system. And what does that mean? Well, basically over here I have this project that I brought into Blender, which is also free. It's open source, and it has a lot of capabilities that some of the big boys have. And so for me, it's really decent. I actually modeled the majority of this stuff in Lightwave 3D, which is something that you pay as a commercial software, but some of the capabilities in Blender, I have to say, probably work out better than Lightwave. This is a complete polygonal modeler, and so what does that mean? I mean, you can see I have some textures on it already, and I painted that in another program. There's some problems that I had to fix around here because the translation didn't work. I had to close up this gap right here, and we can go ahead and, I don't know if I have it on lighting wise, but we can try to render it. I don't know if it's going to work though, because so we kind of look like that. So there's a lot of work that can be done, putting backgrounds and stuff like that. But a polygonal modeler basically is where you build a model using polygons. Let's just isolate this here really quick, and then we'll go into edit mode. And what you see here is a lot of blue dots. And the blue dots, if you remember your geometry, are called vertices, or a vertex. One of them is a vertex. They're connected by edges, and they make a polygon. And you can see there's a lot of them in here. Now, I don't actually draw every one of those individually to make this thing. There's different types of modeling methods that can be used. But when you get to this point and you're freezing, what we call freezing the mesh is like freezing this stuff in, then it gets to be really hard to edit, because when you move stuff around, it just kind of, you'd have to move a whole bunch of stuff, and it gets to be really unforgiving. And even though I could have designed this stuff totally in here, the accuracy that I get out of it isn't all that great. And I don't really have a parametric modeling system. So what does that mean? I think I'm going to have to close out of Blender here really quick so I can save up on resources. But basically things are locked into place here. You can eventually animate it and put things called bones and armatures in it and do all this other fancy stuff and make things render out. But basically visual effects software is just out there to trick the mind. That's all there is to it. Trick the eye into thinking things are real or within a certain amount of scale. So you get a little bit of artistic license with it. You can just throw things in there, make it look neat. This is from like my past childhood type of model. But let's go ahead and open up what I did before, if I can find it. Now this is going to be a little bit different. So this is how I started out. I got some models with a hand, or I got some pictures of a hand, and then I basically used that as a guidance, and they tell me that this is supposed to be a female hand, and I can tell because of the delicate nature of this part and the tendons and how those things fit together. But that gave me a guideline, and I just kind of threw all the rest of this stuff in here. But the main part that I wanted though is the hand. And so the hand was all modeled like this, and then I took it in and I sculpted it. Now this looks a lot different because this mesh isn't frozen, and we call this subdivision surface modeling because all these straight lines on the outside here make up a control cage. So if I move one of these, it moves it in a smooth fashion like that. And so underneath all that, if we turn here, and let me see if I can get off optimal display, you can see all those other little tiny divisions in there. That's the subdivided part that I can't touch. And the other model that I just showed, it's already frozen. And so all these become real, all these little lines become real. But when that happens, it becomes harder and harder to edit. But I just needed a template for a hand. And the template was used basically to model the rest of the stuff around it. And so usually when I stretch Micah's arm out, and I try to keep it stretched because some of the muscles on this side where the radius would be that may still exist, they start to contract and they start forming scar tissues and stuff like that. So I stretch it out for her, and I make her do finger exercises, try to turn it into a game for her so that she can exercise. But this is about as straight as I can get it. And this would be that little knob at your wrist. This is the thumb side. It's missing. So we have this part here, and this little bump here is usually referred to as the ulnar styloid process. It's the very end of your ulna bone. And so setting all the wrist bones on top of that is one of the goals of the surgeries. But we're probably not going to go through with the surgery. We don't know. We're still kind of looking into things. We may wait until she's older to tell us whether or not she wants it or not. So, but she's got pretty good function through here. She bends great here, less than great here, even less here. And so usually the functionality is lost. That can be lost when they straighten these things out, and you could actually end up making it detrimental to them. The function just isn't there. So they usually scissor things with their fingers. They use this as a thumb. I've noticed Micah use her thumb on the other hand as a template on how to use this finger. So she's learning how to use it. It's just a hard decision. So anyway, I had a template like this. I had drawn out a sketch, and then I just drew in some angles so I get an idea where that angle should be. And the greatest thing is that I couldn't give her that much functionality with a thumb, because the thumb has to oppose to do any good. It doesn't matter if you lace it up against your side of your hand. It doesn't do any good if you can flare it out and stuff like that. What does the most good is if you can bring the tip of your thumb over here to the base of your pinky, and that's called opposition. So that's how I wanted to design it. So this is my first little attempt at getting a rough idea of how I wanted it to do. Originally I thought, well, maybe 2 pieces, I could adjust it so she stretches out through here, this could snap in. Well, I ended up designing this for a kid probably of about 5 or 6 years old, and the tolerances are really small. So to have components this small is going to be very difficult. So back in Fusion, let me close that in a second. Back in Fusion, what I started out with is just the basic principle of the thumb, and so the thumb looks a little bit weird, and I started out small because she is small. So the tolerances in these things are really tiny. The radius like 0.35 millimeters, and so my diameter of, let's see here, selection 2 here is a whole 0.7 millimeters. Now the whole idea of this is to eventually bring this, because you can take all these models out and you can get them 3D printed. But the tolerances on the 3D printers that you can buy and put on your desktop vary quite a bit. And sometimes they don't get down to those very, very small tolerances. And so I'm not really sure this is going to print out. Maybe she would have to wait until she's older. And I'm not really sure how I'm going to articulate it to oppose things. So what we have here is the base of the thumb. It was built up of a bunch of sketches that I don't... usually we sketch out all the different parts, and these aren't even all of them. There's even more sketches within each part, and guides and all that other stuff that help me build the rest of the object. And this object has been moved from its point, but it doesn't really matter. As you can see, these parts make up the sketches for the holes and things like this over here. They're not lined up with anything, but this model here is always referencing these. So if I make any changes on these things will update, and that's what it means by being parametric. Usually everything's driven by a parameter, So if everything's driven by a parameter, if I change those parameters, then all the parts that are associated with that will update along with it. So as she grows, or if I want to change the design, I just change certain parameters and it updates the entire model. And so it makes it very, very nice to use. Let's get rid of some of these sketches because they get to be a little bit annoying after a while. And somehow how I put it together, I can't get rid of all the sketches all the time, so because I had to dig into where those are. And so what we're left here is with the base that I wanted to have connected into the brace, but it's easier to design the thumb in a planar fashion, which means straight up and down, left, right, up, down, back and forward. Making anything at an angle really sucks to get any type of accuracy, and then there's certain tricks that you have to do to get things to work correctly. So what we have here is we have just basically, let's start with the tip of the thumb here. Tip of the thumb was rounded, and so I had an idea that this was going to be covered in something like a silicone so that they could use it as a grip, be waterproof, so on and so forth. We have the joint pins that I actually modeled by themselves because I could find parts that were small enough to fit in this hole, but they were metallic, and they usually they were either riveted, which would really suck trying to get them apart. Well, this is going to really suck to try to get apart anyway. And or they were threaded so that every time this thing actuated, there could be a chance that it would back out, and so you'd always have to tighten it. So I didn't want to do that, and I figured, well, I don't want to buy extra parts, so I just want to print them out. And so I designed some joint pins, and these are pretty simple pins. Sorry, it's been a while since I've used this, but one fits inside the other. Okay, so the female portion is gone, so this is the male portion. All it does is just slip in there. It has a gap in it so that it can be compressed when it's pushed in from one side, and then it locks. It has a flange here that locks, and then the female edge is like this, so the male edge fits in there, and then there's a small edge in there where it locks in. But after you snap it together, it's pretty much snapped together. Now again, I'm not sure if this is it's even going to be possible to print something like this, because like I said, the tolerances on a 3D printer vary. It's a plus or minus this and that. And so my diameter for just this part here is 1.45 millimeters. May or may not do well, and plus the clearances I try to build in here where they snap together, those are usually really suspect, but at least these don't have to rotate around one another. They just have to hold the part together. They have to hold part of the thumb together. And so I don't have to worry about that too much. I just wanted to have enough gap here so that, you know, expansion while it's printing and all this other stuff, it wouldn't bind up. But we may have the problem down here. I don't know. It's all an experiment. So those were the joints. I'm not going to say that part. So back to the thumb. I had to figure out a way to retract the thumb, first of all. And so this is this channel here, and it's just going to be a piece of probably elastic cord that runs down, and I haven't made a mount to where it's going to mount to the brace yet, but it would run the length here, and all that would do is a passive tension type of thing where it would pull the thumb back. And then up here is just another channel for how we're going to try to oppose it or flex the thumb. Now it looks like there's too many joints here. Many people will look at this, oh, that's too many joints, that looks like an index finger. Well, this is usually covered by this is what we would call the metacarpal of the thumb, and so the metacarpal is usually covered by it's where your webbing, the end of that is where the webbing in your hand connects, and then this goes down and connects into the wrist, and it's usually surrounded by several different intrinsic muscles, tendons, and ligaments. And so we don't really see this, we only see these two joints in our thumb, these two little phalanxes in the thumb, so that's all we really needed. I also needed a way to make that webbing, and I'll show you how that is, how that works out. And then this joint down here, sorry my navigation is different, is where it would kind of connect at the wrist, where it articulates with the wrist. And then this was just a generalization, like, okay, I'm going to get close, and then we'll see when we get to the brace part of it how we're going to integrate that stuff, and that's what I did. I also built in some limiters for hyperextension because I didn't want it to hyperextend, and so there's some tabs in here. And let's get rid of this distal phalanx. And so we have a tab right here, and then the distal phalanx has another tab that fits along this surface when it rotates back, and so it prevents it from going back all the way. I thought it gave it a little bit more of an elegant design because it's more thin, more along a bony, elegant type of approach. And I'm pretty sure that this design is going to be changing at some point in time, but you know. And that's all there is to it. As long as you can have these things articulate, it's basically the stylistic from that point on. I even had designed some washers in the middle here that will be printed too. So the whole idea is to eventually just 3D print every single part of this. So we got rid of the thumb part, and I didn't really change anything. So we got to the hand, and so this is the imported hand, and it doesn't look like the polygonal model that I showed you before. It's unselectable right now, so it's not going to highlight much of anything. But basically, I needed a template for this to snap to, so that would be form-fitting. Now I don't really have a model of Micah's hand, but I approximated, of course, and the other stuff, and then I molded this to it using an approximation, and this is just a base mold for the brace, and that's it. So the internal part is going to be like urethane, maybe, or neoprene, or some sort of spongy material. Eventually there's going to be slots for air movement through here, and there's also going to be, you know, areas to put a strap across it so that it, you know, stays on. Obviously it has to stay on somehow. You can't just slip it on, obviously. So we got to that point. I had to have that thing. So this is in Blender, the hand in Blender, which was easier to model there with a polygonal approach, and then converted into this weird looking thing. It did this conversion on its own. It looks really funny, but it serves its purpose, just to give something in the background for this to form fit to. And then we ended up integrating all of that stuff. So obviously that base changed, and something's wrong with the texture mapping in here. I don't know why it doesn't adjust the scale. Obviously the weave and this type of stuff isn't going to be there, but let's see what the webbing shows. Yeah, which one is it? No, not that one, that one. Okay. Oh, you're supposed to hide that. No? You're not going to hide that? Well, isn't that special? Almost like that's an extra piece there. I don't know what the heck's going on with it. So we still have the hand mesh that we designed it around. I have something not working right for me, so I don't know if I could show you. Yeah, it's supposed to be hidden, so I don't know. Oh, maybe it's because it's not active. Hello? You know, it's not wanting to play right. So we'll do this. There we go. Alright, so I can kind of hide that a little bit. So this is the part where said that this is the metacarpal and it has to have a webbing in it. And I thought, well, there's not going to be much utility without a webbing. So I haven't finished the design yet, but it's just going to be like a little strap in here that's tethered on each part. And that'll create like a reinforcement underneath this other part. And hopefully it shows that. So there's other underneath this part, which represents the other part of the webbing and the musculature. Now, this part isn't really going to be manufactured by anything other than just cutting it out and then finding a way to attach it to this part. It's going to be a cloth, and I think what I'm going to do is change it even further so that it wraps around here somehow, instead of just terminating right there. Let's bring everything back. So then you have a webbing here, and this is just a representation of a cloth. And somehow, I don't know what's wrong with this texture mapping. Like I said, these are way too big for a weave representation. But I also gave this surface a little bit of a cutout so that she could use her actual polymer surface. And then it's designed so that this collapses and it opposes over to here. So it looks a little bit big, it might be, but we're going to drive this over and try to oppose it over here. And so how we drive that, I don't know yet. I have no idea yet. I don't know if I'm going to have it driven by, say, her bending one of her good fingers that can actually bend fairly well to, somehow articulate this to bend it. I don't know if there's going to be a servo that's strong enough to bend it, because after you do bend your thumb, the grip that your thumb gets is from that opposition part this way, but if you're just going to hold something, it just has to be able to hold the load this way. So I'm not really sure. Of course, I had to put more holes in here for venting. I'll have to put something for a strap somewhere around here that's a little bit more comfortable. But like I said, all these tolerances are really, really small, so I don't even know if it's possible to do. You can see that the base had changed down here, and then it's been integrated into the brace itself, and so that design had changed. But I think this is a good start, at least to try to help. And I don't know. I don't really know. We'll find out. It's just like one of these things that I designed inside my head, so it didn't take as short a time as somebody that would concept sketch it out. I did concept it, but every step of the way in construction I stopped and I thought about it, sometimes for days, just to see how this thing would work. And I played it out in my head and over again, and what are the requirements and what do I need to move it, and so on and so forth. So yeah, it just takes me a while to get that done if I don't have a concept and just go head first into it and just knock it out. But what is this part of my history? Yeah, I could have done that and gone back in history. And then we take another step. You can see how I've refined stuff. So this is the history, and if I capture the history, you can kind of see how I've built up certain parts over time. So yeah, that's where we're at. So what does it mean to be parametric? Well, what it really means to be parametric, we'll just draw something here really quick, and then I'll just so basically what we have is a box and a circle, and that's not too special, and so we'll dimension that, and well, are you going to dimension? There we go. These dimensions don't show up anywhere, so And once things start turning black, then we know that things are locked in here. And then we're going to dimension this center point to that. No, don't do that. I'm going to dimension this to here, to here. Come on, go straight. There you go. Good job. And we'll just dimension the radius or diameter there. And so now everything's black, and so I have everything I need. So I want this to stay a hole. And the best way to do that is just come over here, take this, and then we're going to extrude it, and we're going to tell it to go up about 10 millimeters. Oh, not 100. Not 100. Well, 10 millimeters. Like this. And so all these are driven by those parameters or dimensions that I put in there. So what I can do is if I wanted to move this hole over just a little bit more, then I can go into my sketch. I can turn the sketch on. I can tell it to edit that sketch. And I said, well, from here to here, maybe I just want a 5 millimeter gap. I want it to be put in here. So I just go over here and put it 5. And then maybe I want to do the same over here, but I want to put it 10. So it's going to be 10 out there. And maybe the radius isn't correct. I can go 25. And so when I do that stuff, when I stop the sketch, you can see everything else updates on the model. So it goes really, really, really quick. And then when I want to add a fillet to something, which is like a rounding of stuff, then I can, ooh, that's a little too much. Let's try just typing it in. There we go. I can do that. And then let's say I just hold down the control. I want to apply it everywhere around there. Maybe we want to round it around there, of course. Why not? Let's see if we can do that. Okay, so that's pretty quick. All right, so got all that stuff done. I told you I didn't want that. Yeah, it's supposed to be food. Oh, well, that's why. Okay. So this is all we have here. And then if I wanted to say, oh, well, that's getting too close to the edge again, then I can come back here, go, oh, well, let's me edit a sketch. I don't know why that's clear over there. And we'll go back down to 10. Like that. Okay, so now I have my little hole in there. And so I could just update this whole thing. And if this was an entire assembly and that they were related to one another, then everything that was associated with this hole being drilled through things, then those would update all down the chain of things. And I can even go back in here and I can go edit feature and I say, well, I don't like that. Maybe I want it 0.5. Okay, so I can always go back and change things, and that's what makes it a little bit more special than anything else. CAD software is really awesome at doing this, but CAD software is also not always as forgiving as Fusion 360, and I think it's like one of the best products out there, and it's still being developed. And really, if you need to design anything, go ahead and use it. It's not, I wouldn't use it to design like a house or a building or anything like that, but you can use it to design components of a house, like, you know, countertops, windows, blah, blah, blah. And of course, anything mechanical. You just have to sit down and really just try to work with it a little bit. And it doesn't really take that long when you get to used to the tools. And so I can go ahead and, well, let's go back up here. Cut that out, hit a fillet here, maybe chain that selection, go 0.5 on that. That looks pretty good. So you can cut out anything you want, put things together. It just there's just a different design approach between CAD and some of the polygonal software stuff. So really good at using, or really good for designing parts such as that that thumb. So anyway, that's where we're at, and sorry if I've been rambling a little bit too long. I've just had kind of a rough few days. Been dealing with an infection. Went back to work the last couple of days. I think I just overdid it. So I know I'm kind of scatterbrained and I'm just not up to par with it. But I thought I'd tell everybody how I got to this point and the things that I used in order to do it. So that's it.